over control of the screen. So let me mute and you should be ready.
All right. Okay, my name is Charlotte Peyton. Welcome to our course on GMP Laboratories. My background, I'm basically an analytical chemist with 30 years experience in FDA and EPA industries, done a little bit of everything from starting on the bench all the way up to running the lab. So as we'll see later on in the presentation, you have to have experience, education to be a presenter. So. All right, some of the goals and objectives we will try to get through: understanding FDA regulatory requirements for laboratory, current good manufacturing practices, also known as CGMPs, as it applies to all industries, what the FDA authority and enforcement of the rules and its applicability. EAS has particular guidance and recommendations to help ensure compliance. And we will go through the essential laboratory operations. And we will also at the end have a section on either being or using a contract laboratory. So here's our agenda for day 1 and day 2. It is, as Amy said, a lot of material. I tried to condense it down for our 5 hours over the next 2 days. And I really didn't want to leave information lacking for you guys. So there's some of this I will go fast and I will kind of skim over it, but I wanted to make sure that you had the written material in your possession. So we're going to do an introduction, go over personnel, laboratory facility, equipment and instrumentation, how to do sample tracking through the lab, going over chemical and standard management, documentation and data management, quality incident systems. Day 2 will be specifications and testing, material and product qualifications, test method validation or verification, out of specification investigations, stability programs, and then that being or using a contract laboratory. So this is a basic overview of GMP in the beginning. The FDA is responsible for protecting public health by ensuring the safety, efficacy, and security of human and veterinary drugs, biological products, medical devices, and by ensuring the safety of our nation's food supply, cosmetics, and products that emit radiation. Some background history on the FDA. The FDA came into existence in 1908 with the passage of the 1906 Pure Food and Drugs Act, also known as the Wiley Act. It prohibits interstate commerce of adulterated and misbranded foods and drugs. Prior to this, there was no requirement for drug efficacy. Nobody had to prove that it worked. And before the FDA was established, there was a book written by Upton Sinclair in 1904 called The Jungle, and it was kind of an expose on the meatpacking industry at that time. There were horrible unsanitary practices, and that book really got people concerned enough that Congress had to act. Previously to the FDA, the only enforcement was by the Bureau of Chemistry that was founded in 1882. So the Food, Drug, and Cosmetic Act, FD&C, passed in 1938. And again, that was prompted by a horrible incident that happened in 1937. There was a formulation chemist in a drug company who decided to improve a antibacterial medication. And this formulation chemist decided to use diethylene glycol, which is also antifreeze, in their formulation because it had a nice taste to it. And as a result, nationwide, we lost over 100 people, 71 adults and 34 children that died. And so the FD&C Act was the first uniform federal standard for the safety of food, drugs, and cosmetics. It required pre-approval for new drugs. That was something new. Had to go have a safety review over that. And it made the definition of a drug is a substance that is intended to treat, cure, prevent disease in man or other animals, which was very new. And this enforcement can only be by the FDA. There is no private enforcement. So GMPs, the regulations that are issued and enforced by the FDA to control and supervise companies that manufacture, package, hold, and distribute food, drugs, and cosmetics to the public. The GMPs require that you have a quality systems approach to manufacturing, and they want to minimize or eliminate instances of contamination, mix-ups, or errors. And then this in turn protects the consumer from purchasing a product that is not effective or might even be dangerous. So the GMPs are a system of procedures and documentation for proper design, monitoring, and control of manufacturing processes and facilities to ensure that it has the identity, strength, quality, and purity, which is represented to possess. That the phrase identity, strength, quality, and purity, you'll see that a lot throughout this presentation over the regulations. The small c in CGMP means current, and it requires that you use modern technologies, up-to-date systems, and innovative approaches to comply with the regulations. There's always an expectation of continual improvement that we need to participate in. Your system could have been perfect 10 years ago, it would be behind now. So there's different types of laboratories. You have research and development labs, quality control labs that would offer support to manufacturing, and contract labs. The different types of testing that would go on in those laboratories would be physical testing, chemical testing, microbiological testing. So the Code of Federal Regulations, the CFRs, there is a set of regulations for every one of these industries. And you'll notice that for pharmaceutical drugs and veterinary medicines, there's subcategories that also have their own sets of regulations. Here's a list with the number and official name for each of those sets of regulations. The ones that we'll be looking at most closely will be 111 and 211. GLP is good laboratory practice, incorporates a set of principles that provide a framework where laboratory studies are systematically planned, performed, monitored, recorded, reported, and archived to ensure the uniformity, consistency, reliability, reproducibility, quality, and integrity of test data. That was introduced in 1978. And then we also have GDP, which is good documentation practice. It is the standard by which documents and records are created and maintained to ensure integrity. Those written documents should comply with the 5 C's that are clear, complete, concise, correct, and compliant. So both 111 and 211, 111 is dietary supplements, 211, ooh, I went too fast. So 111 and 211 both have subparts that mention in particular records. A lot of people will say GMP stands for get more paper, get more people. I've heard of giant mountains of paper. The one phrase that keep in mind, if it's not documented, it did not happen. That is the way the FDA looks at it. So you have to keep records on everything. So the two words here you need to really pay attention to is misbranded and adulterated. Those are the words that the FDA will use with any enforcement action. Products are misbranded within the meaning of Section 403 of the FD&C Act when products fail to meet label claims or labeling requirements. Products are adulterated within the meaning of Section 402 G1 of the FD&C Act when products have been prepared, packed, or held under conditions that do not meet CGMP requirements. So for misbranded, a product is misbranded if what is claimed on the product label does not match exactly what is in the product. If the label or labeling is false in any particular way, and if it does not comply with labeling regulations. You will notice the first two directly are involved with product testing and laboratories. And then for an adulterated product, if the product contains anything that is potentially harmful, if it's an economic adulteration, meaning that if they put something else in the product because it was more profitable than what should have been in there, if the manufacturer, if it is manufactured or held under putrid or filthy conditions, or if it is produced in a facility that is not in compliance with CGMPs. And again, that first one is directly, or the first two directly involved with product testing and laboratories. So it will be of interest to us. The FDA has to establish authority. One of the first documents or sets of documents they will ask for when they come to do an inspection is your distribution records. They're wanting to establish that you are engaged in interstate commerce. Once they've done that, then that holds into this regulation that defines that the FDA may enter at reasonable times any factory, warehouse, or establishment in which food, drugs, devices, tobacco products, or cosmetics are manufactured, processed, packed, or held for introduction into interstate commerce. That's the main part they're looking for. So the FDA has authority over a laboratory to come and do an inspection. The most common reasons for inspections is that lack of GMP compliance, ongoing compliance programs, or if there's any complaint or recall investigation. The FDA has different options available to them for enforcement. Under administrative, the first thing that they would do would be to issue a 483, which is called a list of observations. That might escalate to a warning letter and could also be involved with product recall, suspension of a facility registration, or debarment. They also have legal options. They must work with U.S. attorney offices to bring actions. They don't have legal enforcement on their own. That legal enforcement, though, could involve product seizures, an injunction, which we call a consent decree. It could involve legal action. It could involve significant civil money penalties or criminal liability up to and including jail sentences. So a 483 would be the first issue you would have with enforcement. That would be issued and discussed with management at the conclusion of the inspection. It's not going to be a surprise to you. They'll come in and do an inspection for 1, 2, 3 days, and then they'll meet with you at the end and present their 483 and then discuss it with you. There would be a factual listing of the items requiring corrective action. You would be required to give a response in writing within 15 business days. And the thing to know about a 483 is that it can only be accessed through the Freedom of Information Act. It's not readily available to the public. If your 483 escalates to a warning letter, you would be, that is normally issued between 6 and 10 months after your 483, or it's issued when a drug claim is made on a dietary supplement. We see that with hemp products as well. If you're in that dietary supplement category and you try to make a drug claim, they won't even come see you about a 483. They'll just issue you a warning letter straight away. That warning letter would also have factual listings of items requiring corrective action. You also have 15 business days to respond. But unlike the 483, a warning letter is public purview. It's published on the FDA website every Wednesday. There is an ability for you to sign up with the FDA to be contacted with those warning letters every Wednesday. I would highly suggest that you do that. It's got a lot of good current information in there on the thinking of the FDA. So some reasons why that you might get a warning letter from an inadequate 483 response. If your response was too general and not focused, if it did not address the systemic or global issue, just a specific observation. And what we mean by that is if they gave you a 483 on product X that you had in your stability program, and you didn't check to make sure that the rest of the items in your stability chamber have the same setup, then they don't want you just to pay attention to the one thing they said. They want you to look at it in a bigger context of your systems. So if your corrective actions do not address the actual root cause of your problems, if you have no supportive documentation or evidence for your corrective actions, and if your follow-up responses for long-term corrective actions are not provided. So they want to know in your response exactly what you're going to do to your systems moving forward to make sure it doesn't happen again with anything else. So we compiled a list from all the warning letters between 2010 and 2017, took the top 10 and started crunching numbers. You will see that testing at 41% of everything in the top 10 is by far the greatest numbered items in the warning letters. Specifications, which are closely related to testing, is right behind that at 39%, practically the same number. After that, it's master manufacturing records, batch production records, then QU operations. A nice visual of that and a pie chart shows you just how much the laboratory and testing is involved in all these warning letters. So it's very important. So the FDA also has at their disposal legal enforcement. They can do seizure, which takes a court order. It's possible that the FDA would take possession of non-compliant product through that, and it might be more than one product. You could get an injunction, which is known as a consent decree, that also would come through a court order, and it would be the result of inadequate 483 and warning letter responses. At a consent decree place, they could actually shut down your operations until the FDA agrees that you are compliant. There could be civil monetary penalties, although these are very rare in supplement cases. They're usually involved when there's some aspect of consumer fraud. So consent decrees are issued by the federal court at an FDA request, and the company will consent to the content of decree. It's like when they ask you to do a recall, you can't really say no, right? There's some stipulations. There must be admission that the defendants manufacture and distribute adulterated drugs. You have to agree to cease all production and distribution of products. You must destroy raw materials and products in your possession within 10 days. You must immediately recall and destroy all unexpired products under FDA inspection. And then most likely it's going to be for the last 2 to 4 years. You will need to notify the FDA 60 days prior to your intent to resume production, where the FDA will re-inspect your facility before production. They're also going to bill you for the cost of them coming back out and inspecting. They normally don't bill you in the beginning, but they reserve that right to do that for you after they've tried working with you and you don't comply. They also will require for you to retain an independent expert to conduct the initial GMP inspection, and then do that again every 6 months for 5 years. And then they want that certified in writing to the FDA. What this tells you, it is in everybody's best interest to address those 483s right off the bat. It never is public. You don't have to escalate to a warning letter. And once you get to a consent decree, it's extremely hard to dig yourself back out. You have to have a really big bankroll to be able to do that, because you will be no longer producing, no longer making any money. You have all these systems to fix. And then you have to, like, even when you're ready to go, you have to notify FDA 60 days prior. So it's just an extremely difficult situation to get into, or not to get into, to get out of once you've gotten into it. FDA also has at their disposal criminal enforcement. Every violation of the FD&C Act is potentially a criminal offense. So again, that's at the FDA discretion. If they have come to the conclusion you're a really bad player, then they can just keep coming at you with more things. This misdemeanor, there is this United States versus Doddridge in 1943 and United States versus Park, and that's supposed to be 1975. These were where they came after the CEO and they came after the president of the company. You cannot push your responsibilities onto your contract lab, onto your contract manufacturer. If you're in business and you're selling a product, you're responsible. And they'll carry that responsibility all the way up to the head of the company. It can be a felony. You can have an intent to commit an offense. They have to be able to prove that, though, that you had intent. And also, if you get a second misdemeanor, they can elevate it to a felony. They have federal sentencing guidelines for this. Mainly that there will be restitution to the consumers, and they want to make sure that you have been disgorged of your profits. Here are some examples of other companies that have gone through this. Peanut Company of America had a salmonella outbreak, killed 9 people. The melamine and wheat gluten had pet deaths. Deaths and injury are places where the FDA will, really get involved and take care of things. So laboratories should be educating themselves so that they can identify and address all of the major violations in their facilities. Need to thoroughly understand the cGMP requirements that pertain to the type of materials and products that they test. You need to read those warning letters and inspection reports. I would really suggest you sign up for the FDA warning letters. Very useful. Familiarize yourself with the FDA's compliance program. And you need to understand how to properly respond to 483 letters. It is suggested that you get counsel, an attorney that specializes in that, along with a consultant. That is your best chance for stopping your problems right there in the beginning and not letting it escalate. Remember that the FDA warning letters always contain a statement reminding companies that the list of violations are not all-inclusive, and it is the company's responsibility to ensure their products and facilities are in compliance with all applicable laws and regulations. Recommend that companies immediately have qualified experts perform in-depth GMP audit and gap analysis of their facilities and their products. And then based on the violations and deficiencies found, they want comprehensive corrective actions to be aggressively implemented. Did anyone have any questions on that section? No?
Charlotte, let me just take over the mouse real quickly so I can scroll through and see if anyone has a hand raised. Sorry if I'm moving your slides, I apologize. Okay, I don't see any hands raised. Let me mute and you can take it away again.
Okay. Okay, now we'll go over personnel. Personnel are the most important resource that a lab has. It's our suggestion that you hire really good people and then continue to develop them. They will have definitely scientific background. You'll have chemists, microbiologists, other types of scientists, and then technicians. Training is essential to properly perform and control your operations. And just be aware that employee errors account for a large percentage of product defects and then CGMP non-compliance. Here are the regulations for 111 and 211 on qualified personnel. The thing here to notice I have in red, they're looking at education, training, or experience. And you will see that string of 3 words repeated over and over again in the regulations. When it pertains to supervisors that are qualified, same thing. They go back to the education, training, and experience. So laboratory personnel will be scientists. They will have chemistry, microbiology, other types of scientific degrees. Laboratory experience is greatly useful. You want for them to be able to know safe use of chemicals, bacteria, yeast and molds, real thorough knowledge of laboratory processes, and hopefully you will have subject matter experts of these different techniques in your group. So quality control, a planned and systematic operation or procedure for ensuring the quality of a dietary supplement, and then quality control personnel, any person or persons or group within or outside of an organization who is designated to be responsible for quality control operations. And then here are the regulations that pertain to that. Common industry practice is to call quality assurance like the oversight operations for quality, and then quality control would be the technical people that do quality functions, and then the laboratory operations. The FDA does not make any distinction between that, so when you're reading through the regulations, it's a little confusing. Oftentimes anymore, people just refer to that entire group as the quality unit or QU, and that way you don't have issues with the definitions. So employee training must be properly managed to ensure appropriate training related to functions is received for whenever you have new written procedures or you revise those procedures, any manufacturing process, anything to do with equipment and instruments, or with your methods, your analytical techniques. Oversight of your training program should be done by either a training department or your quality unit. And then you want to use your qualified technical trainers or appropriate subject matter experts while doing this training. So the first thing you need to do for your training plan is establish a training SOP and have that in place. You want to establish a training matrix that is different for each department, has different modules, matrices, and relevant SOPs for each position. It's not important that a beginner chemist knows everything in the laboratory, every single SOP. You need to establish for each job title and description what those SOPs that pertain to that position. Refresher training and then requalification is important. Corrective actions for any deviations, errors, or failures in your training records need to be timely, documented, and then filed in the training folder. So this is the 211 regulation for training. Also mentions, all right, it's gone. So language issues for non-speaking, non-English speaking employees. If you have documents that need to be used by either English as a second language or they don't speak English at all. It's very important that you have these documents available to them in their native language. You need to have SOPs, job descriptions, training presentations, specifications, and test methods. Have those documents both in English and the other language is best practice. Another thing that I've seen recently is a single document that would be in one language for the paragraph, and then underneath it, the paragraph is repeated in the second language. So that way you have one document and everything's in there. So you're going to need lots of documentation for your training. You're going to need a job description for each position. Gives a description of the required education, training, and experience that's required, and the responsibilities for each assigned job function or title. You're going to build a training record for each employee. It's used to document that each individual possesses the requirements indicated in the job description. This will include both on-the-job training as well as prior education and experience. So in the education and experience column, you're either going to have a copy of their resume, their CV, a job application, a biography. For their particular training, you're going to have documents on the job training. And important for you to understand the difference between read and understood versus proficiency training. If I were to be trained on a piece of equipment that I've never done before, I can read the SOP on it, but I'm still not going to be ready to run that piece of equipment, especially if it's very complicated. So I would have proficiency testing at that point after I've read the SOP. An expert would come in, run the equipment for me, I watch, then I would run it while they watch, and then we would have some type of data after it's over with that proved that I was able to do that. The other documents for training might be course attendance, any certifications that you have, and then your CGMP training. So you're going to have training records in your folders, and that can either be a hard copy or it can be an electronic software system. If you're going to do your records in an electronic software system, they must be Part 11 compliant. So that set of regulations goes over electronic records, electronic signatures. It must be well organized, complete, current, and contain the current version of all those items. So if you have an employee that's been with you for 10 years, they're going to have a really thick job training file, or at least it should be. Staffing versus workload. Here's a couple of regulations that go over that. Insufficient staffing and training are major reasons why companies get in trouble with the FDA. The FDA their only concern is safety of the public and the consumers. They really don't care about your business model, your profit, your bottom line, any of that. So anytime somebody tries to give them those types of reasons why they don't have enough staff, just don't even bring it up. We have any questions on personnel?
I just unmute quickly. Okay, we look good. I will mute and you're back on.
Okay. So now we'll take a look at laboratory facility, equipment, and instrumentation. So here are the regulations for 111 and 211 for having adequate laboratory facilities. And in the interest of time, I'm just going to skim these. Your laboratory facility must be suitable in size, construction, and design to facilitate maintenance, cleaning, and sanitation operations. It must have adequate space to prevent contamination and mix-up, and it must be clean and sanitary. The point of this in manufacturing is to protect the product and the consumer, but in the laboratory, it's to protect the integrity of the sample and testing and make sure that nothing is contaminated. The facility must have safe laboratory operating conditions, need a chemical hygiene plan, hazardous waste management, trained personnel, and must have water that is accessible at the appropriate quality standards. And for a laboratory, lots of different types of standards. Your chemical hygiene plan would be a written program that describes the procedures, equipment, and work practices that protect personnel from potential health hazards presented by hazardous chemicals, carcinogens, or toxins that may be present or in use. So for safety, you're going to have PPE for your employees. You're going to have protective workspaces such as a hood. You're going to have SOPs dealing with hazardous and biohazardous waste, how to identify them, use them, and dispose of them. You're going to have an emergency response SOP that goes over location of equipment such as spill kits, eye washes, safety showers, fire extinguishers, fire blankets, and you're going to know how to get out of the building. It's important for the laboratory to understand how they're going to generate hazardous waste, how it's going to be controlled, identified, stored, and disposed of. And you're going to do that according to your local, state, and federal regulations, which vary widely from place to place. I used to work in Northern California in the Bay Area, and there was just a simple rule. Nothing ever went down the drain. And then I moved to Colorado and found they had different rules. So right or wrong, you have to follow the rules in your jurisdiction. So the facility must be maintained in a clean and sanitary condition to prevent contamination or cross-contamination of samples. There are some materials and products such as probiotics and botanicals that have high amounts of bacteria. And then you're also going to be dealing with the major food allergens. You want to make sure that your samples don't get cross-contaminated. Want to make sure that your employees follow hygienic practice to prevent microbial contamination or cross-contamination of samples, and realize that personnel are always a potential source of contamination. Must be required that all employees wash their hands thoroughly with soap and hot water before starting work, after breaks, and after using the restroom. So, in the micro lab, of course, sanitation and hygienic practices are the most critical. Micro testing must be conducted using the aseptic technique to prevent cross-contamination. And be aware that micro labs will have live organisms that they use for growth promotion studies, for validation experiments, and then also that they use for positive controls during testing. National primary drinking water regulations are the minimal standard required for any water for GMP facilities, but then you will have different types of water for different types of uses in the laboratory. There might be distilled water, deionized, and ultra pure USP water that it's called for. So now we're going to look at equipment and instrumentation regulatory requirements. They have to be tracked, they have to be qualified with a validation system, they have to be calibrated, they have to be maintained, they have to be cleaned and have a use program, and there must be lots and lots of records. Here's some list of typical laboratory equipment. It goes all the way from general glassware, all the way through distant instrumentation like GCs, HPLCs, and different types of detectors. It's a requirement that we track our equipment and or instrumentation. You must identify each piece of equipment and instrumentation is assigned a unique equipment identifier or an asset number. You must have an equipment and instrumentation list. A current list of all equipment and instrumentation must be maintained. The list should include equipment description, identification number, manufacturer, serial numbers, model numbers, general qualification, and calibration information. And you must have a system logbook or equipment logbook. That logbook will capture all maintenance, calibration, and non-routine operations of your equipment. It's required that your equipment is qualified. Here's 111 and 211 references for that. If you have electronic equipment, it must comply with 21 CFR Part 11, which is electronic records and electronic signatures. So 111 does have some requirements for electronic equipment that should be design or select equipment to ensure that dietary supplement specifications are consistently met. Determine the suitability of the equipment by ensuring that your equipment is capable of operating satisfactorily within the operating limits required by the process. Routinely calibrate, inspect, or check the equipment to ensure proper performance. Your quality control personnel must periodically review these calibrations, inspections, or checks. You must establish and use appropriate controls for automated mechanical and electronic equipment to ensure that any changes to the manufacturing, packaging, labeling, holding, or other operations are approved by the quality control personnel and instituted only by authorized personnel. And you should establish and use appropriate controls to ensure that the equipment functions are in accordance with its intended use. And these controls must be approved by quality control personnel. 211 has similar ones. This calls for a backup of data that wasn't in the 111. And you can have hard copy or alternative systems such as duplicates, tapes, microfilm designed to assure that backup data are exact and complete and that it is secure from alteration, inadvertent erasures, or loss. Okay, so your equipment and your instruments have to be qualified. A qualification, an instrument, an equipment qualification is designed to demonstrate and document that the equipment is of appropriate design, construction, workmanship, and is suitable for its intended use. There is design qualification, installation qualification, operational qualification, and performance qualification. These collectively are often referred to as DQ, IQ, OQ, PQ. So you have to have a protocol to do this qualification. You're going to develop it, execute it, get it approved for each step. You're going to process to qualify your equipment or your instrumentation. Make sure that is described in a SOP. So a design qualification. DQ is an equipment or instrument to be ordered, will meet its desired requirements for operation of its intended use. The purpose of that is you want to make sure that you're getting the right piece of equipment, you can get your return on your investment, that your facility can accommodate the equipment, that you have available to you a suitable location, that you have the necessary power requirements, and that any ancillary equipment can be available or be purchased. We had to rewire an entire lab once just to be able to put an ICP-MS in there because the power was so much greater than for other pieces of equipment that we had. You also have to prepare for qualified personnel to be on staff, to be hired or be trained to operate equipment. And again, with that ICP-MS, we had to send somebody to training to be able to run that. Your installation qualification, your IQ, the process by which equipment is determined to be of the correct items, ordered, and is installed in accordance to the manufacturer's specifications. This is not a very long or technical type of protocol. It's just going to say that for the location you pick, if it has the correct amount of clearance around it, if the room has the correct temperature and humidity that it needs, and that there is the correct airflow in there. You're gonna make sure, again, for your voltage and your amperage, that you have enough power available to do it, and that you have room and a place for all the ancillary equipment and materials. Your OQ, your operational qualification, again, is pretty simple and straightforward in that protocol. You're just going to see if the power comes on, if it cools down, if it's supposed to, if it heats up, if it's supposed to, if it rotates, if it moves up and down, that you have gas liquid flows, that your system for your software loads, that type of thing. Your performance qualification, your PQ, is where all your measurements are and where everything gets very detailed. Your PQ is a process by which equipment is determined to meet performance specifications and acceptance criteria. So if it has temperature control, like a refrigerator or freezer, you're going to see what that range is, how much it varies. You might do temperature and humidity mapping like you would in a stability chamber. You might have to check the revolutions per minute and make sure that that is calibrated, that there is a pump frequency that is maintained, that you have flow rates that are met and calibrated, injection volumes are met and calibrated, that sort of thing. So now that you have done your DQ, IQ, OQ, PQ, you're going to assign a unique number for identifying your equipment. You're going to add it to your equipment list. You're going to create an equipment logbook. You're going to put a qualification sticker as soon as you're finished with your DQ, IQ, OQ, PQ. And you should never have to do that again, unless, of course, something changes, and it always does. If you relocate your piece of equipment, then you have to repeat your qualification. If you upgrade the software, you have to repeat it. If there is a major repair required, where a major part is replaced, then yes, you have to repeat it. Does not apply if you're doing simple maintenance, if you have some washers or that type of thing where there's like a periodic maintenance done. It has to be a major event that causes you to repeat your IQ, OQ, PQ. Quality controls must be established to ensure that equipment is properly operating and that it continues to meet its qualification parameters. It must include acceptance criteria and the frequency of use. Some examples of analytical quality controls would be like a system suitability, blanks, linearity, detection limits, quantitation limits. For microbiological, you would use positive and negative controls and preparative testing. So equipment calibration, here's the regulation for 111, and it's using the equipment utensil since there's not one in particular. .211 also has it. 211 just does a really better job than 111 of giving very specific instructions. So some equipment doesn't necessarily have to be qualified. Anything that does not have to, I'm reading this wrong, calibrated for all direct and indirect measurements. If you need to obtain an analytical result prior to each use, does not require equipment qualification. So some examples of that would be a balance. You wouldn't do an IQ, OQ, PQ on a balance. You would do a calibration once a year, and then you'd do a weight verification daily if you're going to use the balance that day. Thermometers don't have to have it, pH meters, that sort of thing. Once you have a calibration in place, you're going to document that in your equipment logbook or else on a controlled form. You're going to put a calibration sticker on there. A lot of people like to use colored stickers that you can see from a distance. Green is go, it's good to go. Red is stop, you can't use it. And then like yellow and orange is also used. So on the sticker that has The calibration, you're going to have your ID number on there. You're going to have the date that the calibration was performed, who performed it, and then when the next calibration is due. And that's what you need on that piece of instrument. If you have something that's too large to move out of the laboratory and it's out of its calibration and it's waiting on repairs, really good idea to slap a sticker on that that says so nobody will inadvertently use it when it's out of its calibration, causing you a lot of headaches. And then not required, but a really practical idea to put stickers on things that do not require calibrations. And then nobody has to wonder, up to and including the FDA if they come in for an inspection. So preventative maintenance must also be conducted on all equipment and instrumentation to ensure that it is maintained in such a manner to consistently hold its qualification and calibration parameter acceptance criteria. PMs must be performed by qualified personnel and therefore usually conducted by the manufacturer or a third-party vendor. You can do that, or you can get somebody who's working in the lab specialized training to be able to perform that also. You need to have a PM program that schedules your equipment and instrumentation calibration items with an associated due date. A lot of people will put that in an Excel file. They will list out their piece of equipment, the description, the serial numbers, everything, put their calibration, preventative maintenance in there. The one thing I do want to say about that is Excel is not Part 11 compliant. So that can be an aid, but you need to print out that list and then initial and date a hard copy, and that is your official list if anybody were to ask for it. You can use sophisticated software options with email notifications that are available. Again, it has to be Part 11 compliant if you go the software route. And then you want to make sure that your performance of your PM is documented in your equipment logbook. So you want to make sure you have an SOP that covers your equipment and instrument. It needs to have an operation and use with procedures. It needs to have its qualification requirements in the SOP. You need to establish QCs with acceptance criteria and the frequency requirements. It needs to have calibration requirements and the acceptance criteria, including the calibration schedules. You need to have preventive maintenance requirements, including a maintenance schedule. And you need to have a cleaning regime and have that documented either in the logbook or on a controlled form. Equipment cleaning and use logs are required as records of equipment and instrument management. And here are the regulations for 111 and 211. So the type of equipment and instrument used for analytical testing must be appropriate for its intended use and applicable to the test to be employed. In general, the selection of the equipment should be as simple as possible and not overly complicated. Physical equipment is recommended when applicable. Microbiological testing can be beneficial. And then sophisticated analytical instrumentation is often required to achieve the selectivity and the sensitivity that is necessary. Do we have any questions?
Let's take a look. If anyone has questions, of course, you can raise your hands in the participant manual, or not manual, participant portal. We'll be glad to call on you at these breaks. Okay, I don't see anything. Let me mute.
All right. Now we'll go over sample tracking in the laboratory. Traceability of samples in the laboratory is a critical function. It prevents sample mix-ups. It maintains the integrity of the original sample condition, and it increases the efficiency in laboratory testing. So a sample has a life cycle. It comes in, it's received, it's identified. There is a designation of what test to run. There's a notification to laboratory personnel. It's tested, the data is reviewed, the sample is retained, and then the records are archived. So We like to refer to cradle to grave tracking for your chain of custody. A chain of custody is the chronological history of the sample throughout the sample life in the laboratory. It gets initiated upon receipt of the sample, then the sample is, identification is generated, assign the storage condition, and then the storage of the sample. And then you track all sample movements throughout the laboratory. Every time a different test is done, there's a documentation of it goes in, it comes out. The documentation can be done with a controlled form or through an electronic system like a laboratory information management system, which is LIMS. Again, it has to be Part 11 compliant. So depending on where you're at, sample receipt might be a little bit different. If you have an in-house lab, you might get your raw material samples from quarantine. If they're in process, environmental or finished product samples, you probably obtain them from QA or from production. If they're stability samples, probably be delivered to the lab by the stability coordinator. And then other samples received for investigational or research and development purpose. Those are always the worst ones because they don't have clear instructions with them. Never like those. Contract laboratory samples received via a carrier shipment. So FedEx or UPS or whoever is going to drop your samples. So there should be a packing slip in there, safety data sheet for hazardous samples, and then the sample submission form. So on that sample submission form, it should have sample information, the tests that are requested, a test method assignment, like you may have 4 different vitamin C methods, but they should be telling you which vitamin C method to run. And then there should be specification criteria of pass, fail, and acceptance range. Your sample volume can vary. Large contract laboratories can receive hundreds or thousands of samples a day and might test up to 20,000 samples a month. But a well-equipped, high-functioning in-house quality control laboratory can test 500 to 1,500 samples per month. It's possible, you just have to be really organized. So when it's time to identify your sample, you need to assign a unique number to each sample received. Chronological nomenclature is recommended, and these are suggestions. You could have a material or product information, could be part of your nomenclature. It's nice to have a number that means something when you look at it. For example, you could have year, and then a sequential number, and then an item code. There's lots of different ways to make it up, but it's nice to have a number that means something when you look at it. Stability samples may also use alternate sample ID nomenclature to capture storage stability conditions and the time point to be tested. Suffixes can also be added to indicate when a sample is a resample, a subsample, a second preparation, or an aliquot. That will be the case for retesting situations for if you have an out of specification investigation, if you have a returned product or a complaint evaluation, or if you have stability samples. And you could also have a LIMS system that's used to generate a unique sample ID. I've only had one time to deal with that, and they just are weird random numbers. I didn't care for that. So sample ID documentation. You need to record the sample ID in the sample custody log that contains information about the sample, such as a material or product code, lot number, and a brief sample description. You organize those by sample ID. Affix a sample ID label directly onto the sample itself. Enter the sample ID and the storage into a database for a searchability tool. You can use an item code, lot number, description, manufacturer, lot number, and date received. After the completion of laboratory testing, the test results are also entered into the database, if you have one available. Good documentation practices must be used at all times through the sample tracking process. which includes the initials and date of the person performing the activity that is documented at the time that it is performed. Sample storage. All samples must be stored in a manner to maintain their original condition and prevent mix-ups, contamination, and deterioration or degradation. So your samples might have temperature and humidity requirements, could be ambient, cold temperature freezer. There might be some requirements around light so that you have to wrap them in foil or do something like that. There might be moisture requirements that require desiccant storage. And then security, if you're working with controlled substances, you might have to get that checked into a vault. So samples designated for microbiological testing should be delivered directly to the microbiology department or microbiology test preparation area and stored there until the initial sampling has been performed. Aseptic technique is required during the microbiological testing, and then the assessment of microbiological content may be needed for future organoleptic testing, for instance, for odor or for taste. Very, very important that you give microbiology their samples first, because as a chemist, everybody knows chemists are dirty and we don't pay attention to that. So once that sample is contaminated, that's it. And there's no takesies backsies. So for sample testing, you're going to determine the testing requirements, a raw material specification, your test request form, your sample submission form. Testing requirements must include a test parameter, a test method, and your acceptance criteria. And that is the ICH definition of a specification. You will notify laboratory personnel that the sample has been received, and then you begin to commence testing. You must have a valid or a scientifically valid test method. It must be conducted in accordance with the written test method procedure, and it must be documented using GMPs, GLPs, and GDPs. So microbiological testing, at least in sample preparation, should always be performed first, or a separate microbiology sample obtained for this purpose. That also works. Then you're going to review the data. All laboratory data is subject to a data review process to ensure data integrity. The FDA defines data integrity as attributable, legible, contemporaneous, original, and accurate. You should go through a multi-step data review. The analysts will review their own work first, a self-review of analysis to ensure that all data is complete and that it meets good documentation practices and your ALCOA standards. Then you should have a peer review, a secondary technical review of data to verify appropriate or a valid or scientifically valid test method is applied and followed, and that all data is scientifically sound. Then you're going to have a supervisory or a quality review, which is a verification of compliance to controlled processes and procedures and review of results to specification acceptance criteria. It may also include material or product release by your supervisor. So upon completion of your laboratory testing, the samples are placed into a laboratory retain. The movement to retain is indicated on the chain of custody. Samples are retained for a designated period of time to ensure that there is no requirement for an investigation. Internal quality control laboratory samples are often retained for extended periods to be used preferentially over your product reserve samples. Generally, people like to save their reserve samples for something more catastrophic, like the FDA has come and requested, or there's been a complaint or something. Customer samples of contract laboratory typically only keep for a period of 30 days. I'm sure that varies with the lab. Then you're going to archive your records. All data and All records and data generated for sample tracking and testing of the original must be maintained in the original format, secure from intentional or unintentional alteration for a designated period of time. It must be accessible and made available to the FDA upon inspection, whether it's internal or a customer for a contract laboratory. The duration of retention is dependent upon the sample type and applicable regulation. So maximum storage requirement is 6 years for dietary supplements. That's only when it relates to a serious adverse event per Dietary Supplement and Non-Prescription Drug Consumer Protection Act of 2006. The 6 years is really safe. That way you don't have to, even if there's not a serious adverse event or you don't find out about it till later, you don't want to say, oh, well, I already threw that away. All right, does anybody have any questions on sample tracking?
Let's take a look. Still no questions. I'll mute and you can continue.
Okay. So now we will discuss chemical and standard management. So there's all the different chemicals and standards that would come into a lab and kind of a little bit of a flow chart. Reagents, solvents, microbiological agents, media, reference materials, quality controls, different types of standards, different types of chemical preparations. A reagent is a chemical entity manufactured and supplied by an external vendor, usually a pure chemical compound that is not intended for use as an analytical standard. And then a solvent is a liquid reagent. Biological agents, any microorganism or infectious substance, or any naturally occurring bioengineered or synthesized component of any such microorganism or infectious substance capable of causing death, disease, or other biological malfunction in a human, animal, plant, or other living organism. The deterioration of food, water, supplies, equipment, or material of any kind. And alteration of the environment. So a biological agent use, you have American Type Culture Collection, ATCC, authentic or purchased from a manufacturer in the ATCC licensed derivative, LD program, in order to assure the integrity of the cell line or microorganism. Biological agents must be handled in a Class 2 biological safety cabinet, the BSC. For media, you have agar, a gelatinous substance obtained from various kinds of red algae seaweed and used in biological culture media and as a thickener in foods. Or broth, which is a fluid culture medium, such as solution of lactose or thiogluconate, used to support the growth of bacteria for laboratory analysis. You have media verification. All media, agar, and broth must be demonstrated to be absent of bacteria, yeast, fungi, and mold prior to use, and be able to provide the nutrients to support growth of the same upon incubation. Stability testing, incubate a representative prepared sample of each batch or lot of dehydrated media at 35 plus or minus 2 degrees C for 14 days to ensure no microbial growth. And you also could do growth performance. You inoculate a representative prepared sample of medium with the appropriate stock culture. Incubate the sample at the appropriate temperature and time period and verify that the media supports the growth of the culture. A reference material is a material that has been designed for use as a primary comparator for the purpose of identifying a raw material organoleptically or via instrumentation such as an FTIR or TLC. Reference materials are not considered analytical standards, as they are not always a pure chemical substance. You have botanical reference materials, well-characterized materials for specific plant genus or species, and plant parts. BRMs are typically freeze-dried and ground plant material. There's also reference culture, a stock culture, a microorganism that is a preparation derived from a reference culture that is received from a manufacturer like microbiologics. Chemical preparations, a solution or other combination of a reagent or solvent with other materials used in the analysis of a sample, not the sample itself or the sample preparation. There's mobile phase that's prepared, extraction solutions, buffers. There are analytical standards. Analytical standard is a chemical substance specifically qualified for use as a comparator for the purpose of evaluating the purity, strength, or other quality attributes of a test sample. There is a primary standard, which is used as the comparator and/or the material used to qualify a secondary standard. A secondary standard is a material that has been suitably qualified and evaluated against a primary standard, and therefore can be used as a comparator for evaluating a sample. And then there is a working standard, which is a preparation made from the analytical standard that is employed for the quantitative analysis of a sample. You must designate your standards. Primary standards, all standards procured from USP are automatically designated as primary standards. You can also use standards that are traceable to NIST or to other accredited standardization body, may be designated as primary standards, such as those used for mineral analysis. If USP or other traceable standard is not available, then a high purity material from a reputable source may be designated as a primary standard. Documentation of the purity should be provided on an accompanying C of A. And I would only do that in a desperate last go if you can't find it anywhere else from NIST or USP. Now you're going to qualify your secondary standard. A suitably pure material from a commercial source may be designated as a secondary standard, provided it is qualified against a primary analytical standard. For instance, you might buy a USP standard for your primary and then find something that is definitely more affordable from Sigma Aldrich, and you qualify one against the other. Potential secondary standards are first received as a sample into the laboratory in order for it to be evaluated for at least identity, purity, and strength prior to being assigned as a secondary standard. So your secondary standard comes into the lab, you just check it in as a sample, and you run it against the primary. Pre-assigned acceptance criteria must be applied to the testing. Makes sense. You don't want to make up the rules after you have the answer. So analytical quality controls. There are check standards, which use of separately weighed and prepared standard to verify your preparation. Drift standards, which are a periodic reanalysis of a standard to ensure the analysis system continues to stay equilibrated and does not drift. And that's a drift standard that is like injected from the beginning of the run all the way through to the end. You have fortification samples, samples that are fortified through standard addition to determine the accuracy of the analysis, particularly for test methods that are prone to extraction loss or matrix effects. Blank standards, chemical preparations containing all substances except the analyte of interest to be used to maintain baseline resolution in complex sample matrices. Microbiological QCs, you have negative controls. A negative control is a of a non-inoculated media that is run simultaneously with each microbiological test or set of tests conducted to ensure that there is no microbial growth. And then positive controls of inoculated media are run periodically to verify that the microbiological test method will support and detect the appropriate microorganism. Each chemical or standard received should be accompanied by a C of A and a safety data sheet. Upon receipt, all purchased chemicals and standards are entered into a chemical inventory. So you're going to have your chemical name, the vendor, the amount received, a lot number, the date received, and the storage location. Your date received is noted on the container, usually just with a Sharpie on the label directly. Once consumed or removed, the chemical inventory is updated to show the date discarded. All chemicals and standards must be assigned an expiration date. For purchased chemicals and standards with the expiration date assigned, must be within the expiration date provided by the manufacturer if known. So you can't extend your expiration date past what the manufacturer says. The expiration date of a preparation may not exceed the expiration date for any of the individual components used in that preparation or the manufacturer expiration date. Standard stability studies that demonstrate the continued level of the standard concentration must be used to assign standard expiration dates. If you don't do a stability for a standard experiment, then you must make them fresh every day. Chemicals are also assigned expiration dates based on stability studies, but the type of chemical present is often used for reagents, solvents, and other chemical preparations. Here's some typical expiration dates. Inorganic materials, 5 years from the date of receipt. Organic chemicals, 2 years from the date of receipt. Aqueous, that are solutions that are 100% aqueous, 2 weeks from preparation to prevent the possibility of microbial growth. Aqueous solutions with greater than 1% acid or organic content, 4 weeks or about a month from preparation, as these are additives served to prevent microbial growth. Chemical preparations, greater than 5% organic content, usually give those 3 months from the date of preparation, and hygroscopic chemicals as appropriate depending on their storage. So expiration dating for media, unless specified otherwise from the manufacturer, media expirations are agar, that is dehydrated media, 1 month from preparation, and broths that are from dehydrated media, 2 months from preparation. No prepared media may have an expiration date greater than the expiration date of the dehydrated media. So you can't grab it the day before it's supposed to expire and then have another month out of it. Labeling. Containers of chemicals and standards must be continuously affixed with legible labeling that includes at least the contents, the lot number, initial and date of receipt or preparation, the storage conditions, and the expiration date. So the use of hazard labeling is also recommended and often required by your local fire department. So there are some examples of some labels. The details of the preparation of chemicals or standards must be documented in accordance with GMPs, GLPs, and GDPs. For traceability, unique lot numbers are assigned to all chemical and standard preparations, documented in individual laboratory notebooks, equipment logbooks, controlled forms, or electronic LIMS systems. They must be documented at the time of performance. It must indicate who performed it and when, with initials and date. Each point, step, or stage of the preparation must be documented, and it must capture the calculated concentration of all chemicals and standards. So a standard chain of custody or other standard use log must be generated to capture the use of standards. So chain of custody requirements are also applicable to biological agents. For traceability purposes, the identity of the chemical or standard used for the performance of each test or each sample is documented. It's documented in an individual laboratory notebook or an equipment logbook in controlled forms or in electronic LIMS. It must be, again, documented at the time of performance. It must indicate who performed it and when with the use of initials and date. It must identify of the chemical or standard, the identity of the chemical or standard and the amount of chemical or standard that is used. Chemicals and standards must be stored in a manner to prevent mix-ups, contamination, deterioration, or degradation. All chemicals and standards must be tightly capped during storage to limit possible evaporation and exposure to environmental conditions. Appropriate storage conditions of temperature, humidity, and light must always be employed for chemical and chemical solution storage. Expired chemicals and standards must be tagged as expired, removed from their current location, and designated for disposal. When you leave chemicals that are expired in the general use area, we all know what happens next. Somebody's going to use it. Then there's going to be an investigation. Media storage. Prepared broth and agar are stored at 2 to 8 degrees C and may be used until expiration unless it is cloudy. Broth or agar prepared from dehydrated media may be stored in capped media bottles, sterile Petri dishes, or sterile test tubes. Once solidified, Petri dishes are inverted and sealed in a package or other secondary container to minimize moisture loss. When ready for use, solidified agar in media bottles is carefully warmed in a microwave, incubator, or on a hot plate with the cap loosened. Then you allow the clear media to cool to approximately 45 degrees C and then gently swirl to mix. All right, do we have any questions on that section?
Let me take a look. Okay, still no questions. I'll mute and you're ready to go.
Okay. Now we will go over documentation and data management. So here's that list of all the regulations for the different industries that the CFRs cover. And then most of our presentation will be around dietary supplement and pharmaceutical drugs. The written procedures are mainly going to pertain to these items of 111. Personnel, plant and grounds, equipment and utensils, quality control, components, packaging, labeling, laboratory operations, manufacturing operations, packaging and labeling, holding and distribution, return dietary supplements and product complaints. For drugs, the CFRs for 210 applies. And then for 211 for pharmaceuticals, these are the ones that apply for written procedures. So regulatory subparts call for written procedures. An SOP, which is a standard operating procedure, is a term used by many industries. And of course, there is no FDA definition of what constitutes an SOP. So it is a critical document. It serves as a guidance for company policy. It standardizes the systems used, maintain continuity among the employees, reduce confusion and uncertainty, and it's a great vehicle for training and instructing employees. It should also define, authorize, and set controls for all subordinate documented systems, such as a master manufacturing record or a material and finished product specification. The first one you start out with is an SOP on SOPs. An SOP that governs the use and control of all SOPs should be developed and implemented. The SOP on SOP should also establish a standardized SOP format. The SOP header should include company identification, a title that reflects the activities to be performed, a unique document control number with a revision number, an effective date, and page numbers. Here's an example of a header that you could use that would fit all those requirements. The SOP will be broken down into sections. Common to have a purpose or objective in the beginning, which is a statement of the purpose of the procedure. The next section would be scope, a statement about what the procedure applies to, statement about what the procedure does not apply to, responsibilities, that would be like almost always quality, and then departments or designated individuals. Any references that you use would be in that section, whether they're regulatory, FDA guidance to industry, other types of procedures, other related forms. So here's an example of those first few. I've seen where some people make SOPs and they don't use a numbering system. It is a nightmare to update an SOP that doesn't have a numbered section for you to go to. Other SOP categories would be definitions, necessary definitions, particularly for acronyms. Yeah, very, very useful for acronyms, people that like to use them. Not everything's common. Sometimes they're particular to a company. Safety, you would have equipment warnings, chemical warnings, requirements for PPE, and then equipment and materials. Safety and equipment materials normally go into like analytical methods and that sort of thing, not generally quality SOPs. Here is an example of what these other sections would look like for definitions, safety, and equipment. So the procedure is the largest section of your SOP. It would be the longest and it'll have the most detail in there. Thorough and detailed instructions of each step or activity be performed. Again, you want to stick to those 5 C's of being clear, concise, complete, correct, compliant. You can incorporate photographs to assist with descriptions of complex steps and indicate specific locations for actions. It's nice to use tables to organize your instructions. Provide any kind of example calculations is useful. Use figures to present concepts pictorially. Prepare diagrams and flowcharts to summarize the sequence of activities that are required for complex processes. Flowcharts are wonderful for something that's really complicated. It helps out everybody. And then you're going to provide example calculations. Also a section for documentation. You're going to have a description of forms utilized for documentation of all activities, an indication of other documentation practices for process. Use examples to depict appropriate record generation. And then you're going to have records, maintenance, and retention listed. And here's an example of what that would look like for procedure and documentation. You're also going to have a section for attachments, any type of associated forms, checklists, or other documents that are beneficial. Authorizations, you're going to have a signature for the author, one for a technical departmental reviewer, and then probably quality review and approval. You're also going to have a revision history section in there, which is really useful to see the last several things that have been changed in the SOP. And here's an example of what those things would look like. So a unique documentation identification system must be established and used for all individual procedures. You can use a combination of alpha and numeric characters. The Revision control designation should be used as a trailer. Logical organization such as departmental should be employed for ease of use. So an example is QU, which would be the quality unit. So that SOP would apply to the quality unit. The X would be the number, and then that -01 would be the first revision. Revision control is crucial for SOPs and all other types of controlled documents to ensure that all changes are tracked and monitored, that other reference procedures are also evaluated for changes. Attached forms, checklists, and other documents are updated, that only current revisions of the procedures are in use, that it is traceability for previous processes and product manufacturers, and that the quality unit reviews and approves all changes for compliance to CGMP regulations and other statutory requirements. So those type of impacted documents for change control would be SOPs, master manufacturing records, master formulas, labels, promotional materials, test methods, raw material and finished product specifications, controlled forms, protocols and reports, any facility and system drawings. And again, of course, there's no specific reference to change controls in the GMPs, but there's some parts in here that are kind of allude to it for 111. And then here's some for 211. And again, 211 is more exact. All changes should be assigned a change control tracking number, should be logged and well documented on a change control or document change request form. Completed change control forms should be periodically evaluated for trends. An evaluation of the impact to existing equipment qualifications or process validations should be included with each change control or DCR. Changes must be reviewed and approved by the appropriate departments and the quality unit personnel. Time should be allotted before implementation of the change to allow for training of all impacted personnel. So yeah, you don't want to have something slotted for change in the next day when you submit it, and then you don't have any time for training. All SOPs must be periodically reviewed to ensure they continue to meet the 5 Cs. Reviews should be performed biennially, every 2 years, and by appropriate department personnel. If no changes are required, a record of the review is documented, but no change control is necessary. To make sure that you adhere to your SOPs, use internal audits of the workplace to assess conformance with SOPs. You can do self-departmental, cross-departmental, and quality unit internal audits. Very useful. Clearly identify all required SOP training requirements in a job description and corresponding training matrix. Have a process in place that requests and supports feedback from your employees for desired SOP improvements and integral contributors to change control process. Distribution of SOPs. All employees must have easy access to current SOPs. And some companies don't understand that. They don't easy access. They'll have one set of books and it's in somebody else's office. That's not what they're talking about. Electronic access is acceptable where there are computers are readily available and the electronic control are in place. Excuse me. And that means that Part 11 compliance where everybody has a different password, that sort of thing. Hard copy binders can be located in each department or specific facility areas. And department heads may also have copies applicable to their responsible department. Use of color coding for distributed hard copies is highly beneficial. So you have the original hard copy signs to be one color, and then all the copies are blue or something else. That way you can see right away from across the room what its status is. For document control, electronic originals must be kept in compliance with 21 CFR Part 11. Physical originals should be maintained by the quality unit. Previous revisions of documents must be archived with the quality unit. That's really important if you need to go back and recreate in an investigation situation what was done at a certain time. You need to have access to the documents that were in force at that time. Previous revisions of documents must be archived with the quality unit. All controlled documents should be subject to a formal review process to ensure that they are accurate, complete, and current. The biennial review is typical, but doesn't have to exactly be that. You could do them every year if you want. Employees must be trained on each document revision. So anytime those SOPs or documents are updated, you have to get a new training, and that has to go in their training record. Good laboratory practice incorporates a set of principles that provide a framework where laboratory studies are systematically planned, performed, monitored, recorded, reported, archived to ensure the uniformity, consistency, reliability, reproducibility, quality, and integrity of test data. And then good documentation practices, standards by which the documents and records are created and maintained to ensure integrity. And there's our regulations for 111 and 211 with records. Good documentation practices. Records must be generated and maintained so that the data therein can be used for evaluation as well as for investigational purposes and other periodic reviews. All CGMP records must be generated using good documentation practices. These are the document, you must document at the time of performance. You can't fill it in the day before you're supposed to do it. You can't fill it in the day afterwards unless you make a notation on it. All documentation must be permanent and legible. So no pencils, no whiteout. Has to be permanent ink and legibility. Oh my gosh, some people don't understand. If you can't read it, it doesn't matter that you wrote it down. So you have to retrain some people to make sure that they understand that legibility is required. Indicate who performed the activity and when it was done with a signature or initials and date. Anytime you sign something, initials and date. All numerical entries must include units such as kilograms and be recorded exactly as seen on the equipment. So nobody gets to round. If you're looking at the weight on a balance, you have to record exactly what you see, no more, no less. The units for the kilograms, that sort of thing, you have to write that in every single time, unless you have a table where you have that unit at the heading at the top, and then everybody knows everything under there is in that unit. Any errors must be crossed out using a single line and corrected with a reason given for the change. You not allowed to do write-overs and not allowed to do crossouts. So of those 4 entries on the screen in the upper left-hand corner, somebody wrote something and then they wrote over it because they wrote the wrong thing. So that's wrong. We can't tell what the original entry was. We must be able to see what the original entry was. Down below on the left, they wrote in the wrong thing, transposed some numbers. So they scribbled over it. Again, that's a no-no, can't scribble over it, have to leave it. So the one on the right-hand side is the way that it should be done. To err is human, they expect errors. FDA wouldn't believe a document that looked perfect. So if you write something wrong, it's fine. You just make a single line through, you write down what you really meant to write, underneath it, above it, beside it. So in this instance, it says transcription error. and then it has somebody's date and initials on there. So that's the correct way to do that. Performance of all testing methodologies must be conducted using GMPs, GLPs, and GDPs. Documentation in individual laboratory notebooks, equipment logbooks, controlled forms, or electronic LIMS must be documented at the time of performance. It must indicate who performed the step and when with the initials and date. It must have each point, step, or stage of the test method. Particular criteria or conditions that are required in the test method must be included with the documentation. So that's going to cover your standard, your solution, your sample preparation. It's going to include your extraction conditions, any temperatures, times, or speeds that were used, your equipment or your instrument parameters, any raw data that was produced, the calculations that you used, and what the results are. All laboratory data is subject to data review process to ensure data integrity. Again, we're going to look at that multi-step data review. The analyst reviews their own work to make sure that everything is there and it's all complete. You're going to have a peer review where a secondary technical review of data to verify appropriate, valid, or scientifically valid test method was applied and followed, and that all data is scientifically sound. And then last, you're going to have a supervisor or a quality review to verify compliance to controlled processes and procedures and review the results to specification acceptance criteria. Here's 111 and 211 regulations for records. This discusses record retention. Must keep written records. This is 111 for 1 year past the shelf life with no shelf life date used, 2 years beyond the date of last distribution of the batch. 211, records for production, controlled distribution, components, drug product containers, closures, labels that are required to be maintained in compliance with this part and specifically associated with a batch of drug product shall be retained for at least 1 year after the expiration date of the batch, or in the case of OTC drug products lacking expiration dating, 3 years after distribution of the batch. So here's for 111 and 211 discussing that the records must be made available to the FDA for inspection and copying if they request it. All right, does anybody have any questions on documentation?
I don't see anything. We'll keep going.
You guys are saving up questions for me at the end, aren't you? All right, so we're going to discuss quality incident system. There are several different investigations, types of investigations that you will have to deal with in a laboratory because nothing ever goes perfectly. There's out of specification investigation, out of trend investigation, an unusual result investigation. You're going to have deviations that are planned and unplanned. You're going to have quality investigations. You're going to have change control, and then you're going to have corrective and preventative actions, which are known as CAPAs. So an out of specification, or an OOS, is a test result that falls outside the acceptance criteria dictated on the material or product specification established in accordance to our regulatory requirements to demonstrate identity, strength, purity, and quality. Out of trend, or OOT, is a test result that is not within the general tendency, pattern, or direction of a series of events, conditions, or previous results. The result may or may not be compliant with the acceptance criteria designated on the applicable material or product specification. The most common OOT event is a stability test result that is not consistent with the stability profile generated from previous time intervals or from other historical stability studies. Unusual result is a test result that complies with the acceptance criteria designated on the applicable material or product specification, but it is aberrant, atypical, or otherwise unexpected, exceeding your set action or alert levels, if the target levels are not met, if there is a sudden occurrence of contaminants not previously observed, or unexpected or extraneous chromatographic peaks. The purpose of an OOS investigation is to determine whether the result is valid. Investigations should also be conducted for out of trend and unusual results. Analytical and microbiological OOS investigations should be segregated due to the strategic differences required during the investigations of the impacted material or product. So the two major differences, but the reasons why though you're going to do two different kinds of investigations for that is that analytes for chemicals are generally uniformly distributed. Anywhere you take a sample, you're going to get the same number. But for micro growth of bacteria, fungi, and mold spreads from a specific region. And the example I always see is a piece of bread. You know, you don't get mold that grows all over it. It starts in a corner and spreads or wherever it was contaminated. So deviations. Investigation of a deviation from scheduled processing and or documentation activity. You can have planned or unplanned deviations. A planned deviation and that is not expected to be permanent or recur for a significant amount of time. An example of that would be if you were manufacturing or even doing something in the lab and the material that you were accustomed to using wasn't available and they were out of stock and it would be out of stock for a month. So you use something else. So you plan on that deviation happening. You know it's going to. Your investigation evaluates why the deviation should not be permanent and then what is the root cause of the deviation. There's also unplanned deviations. I've always heard them described as whoopsies. An unplanned deviation is the unexpected occurrence or event that results in variations from your process and/or documentation practices. You want to investigate all relevant background information needed to understand the situation. You want to do personal interviews with everybody that connected with it. Review the pertinent procedures and documentation. You want to do a historical review and trend assessment. And then you want to perform a root cause of the deviation. All deviations should be assigned a deviation tracking number, should be logged and well documented on a deviation report form. Completed deviation report forms should be periodically evaluated for trends. An evaluation of the impact to existing equipment, qualifications, or process validations should be included with each deviation report. Deviation reports must be reviewed and approved by the appropriate department and the quality unit personnel. General quality investigation of an unexpected occurrence or event that may have impacted the quality of a material. You might have had instrument calibration issues, equipment control problems, inappropriately identified or damaged material, other non-OOS or deviation situations. The investigation will include examination of all relevant background information needed to understand the situation. It will include personnel interviews. It will review pertinent procedures and documentation, the historical review and trend assessments, and will include a root cause analysis. All quality investigations should be assigned a QI tracking number, logged, and well documented on a quality investigation report form. Completed quality investigation report form should be periodically evaluated for trends. An evaluation of the impact to existing equipment, qualification, or process validations should be included with each. QIRs should be reviewed and approved by the appropriate departments and quality personnel. Change control. Revision control is crucial for all laboratory controlled processes and procedures, as well as controlled documents to ensure that all changes are tracked and monitored. The other reference procedures are also evaluated for changes. Attached forms, checklists, and other documents are updated. Only current versions of the procedures are in use. That there is traceability for previous processes and product manufacture, and that the quality unit reviews and approves all changes for compliance to CGMP regulations and other statutory requirements. CAPA, corrective action, is an action taken to eliminate the cause of a detected nonconformity or other undesirable situation to prevent a reoccurrence of that. Preventative action is the action taken to prevent the recurrence of the potential issue. Actions shall include specific tasks and agreements to complete with the responsible individual and an estimated completion date. CAPAs may originate from a variety of different sources, including, but not limited to, observations from regulatory authorities, observations from client audits, observations from internal audits, OOS investigations, deviations, quality investigations, change control trend assessments, employee observations and recommendations for improvement, and then facility and equipment malfunctions, repairs, or service work orders. So the CAPA process is that all CAPAs should be assigned a tracking number, logged, and well documented on a CAPA form. You guys see a trend in this, right? All these investigations should be handled the same way. Completed CAPA forms should be periodically evaluated for trends. An evaluation of the impact to the existing equipment qualifications or process validation should be included with each CAPA. An effectiveness check should be performed for all CAPAs to ensure that both the corrective and preventative actions met the intended goals. And the CAPAs must be reviewed and approved by the appropriate departments and the quality unit personnel. That's it. Does anybody have any questions?
We got through that quickly.
I did. I surprised myself. I thought I was going to run over.
Are there any questions or anything that you would like Charlotte to go over in more detail? If you'll just raise your hand. Okay, Charlotte, I don't see a thing.
All right. Well, everybody gets out 30 minutes early.
That's right. So we'll see everyone again tomorrow at 1 o'clock Eastern. And I think you said, Charlotte, tomorrow is a bigger push for day 2. So
it is, but it might end up on time if I go at this speed for tomorrow.
Yeah. Okay, great. If anyone has any questions you think of after we conclude today, of course, we'll be glad to answer them at the start of tomorrow's session. And with that, I will say thank you, Charlotte. Thank you, everyone in the audience. And we'll see you tomorrow at 1 o'clock Eastern for part 2.
All right. Thank you so much.